Hi everyone, welcome to the channel. In this video, we'll learn about the continuation of lists. Specifically, we are going to learn about list methods, list loop, mutability, aliasing, and about cloning lists. So first, let's learn about the list methods. First one is the append method. So append method is used to add an element to the end, to the last position of the current list. And the syntax is current list name dot append followed by the element which you want to append. You can give one element here, or you can give one list here. The extend method adds the specified list elements. Remember that here you cannot add one specific element. You have to use a specific list name or any iterable as parameter to the extend function. So you can add the specified iterable elements to the end of the current list, and the syntax is list1 dot extend of list2, where list2 is the list or the iterable which you want to add at the end of list1. The difference between append and extend is extend will merge both the lists after appending, but append will not merge both the lists. Say for example, I have list1. List1 contains 5 elements, 1, 2, 3, A and B, and then I say list1 dot append of 4, 5. 4, 5 is the list. Okay. So when I use the append function, you can see that I print list1 here. 4, 5 is added at the last position of the current list1, but it is not merged together with list1. Next, I use the extend function and then I say C, D, where C, D is another list. Okay, and then when I print list1, you can see that C, D, which has been given as parameter to the extend function, is being merged with the current list. The third list method is insert function. If you want to insert a particular element at a specified position on the list, then you make use of the insert function, and the syntax is the list name dot insert position comma element. First, you have to mention the position where you want to insert the element, followed by the actual element you want to insert. Fourth one is the pop function. Pop function deletes and returns the element specified by the index. Okay, so the syntax is list name dot pop followed by the index. So if you don't specify any index here, if you just say list name dot pop and then the brackets are empty, then the default index would be -1. That means the last element will be deleted and it will be returned by the pop function. And if a negative parameter is passed, if a negative parameter x is passed, it will return the last element. Next is the remove method. A remove method will delete the element which is passed as the parameter. So here you will be mentioning the element name and deleting the element, and it will remove the first matching element. So syntax is list name dot remove and then the element name. In pop, you delete it by specifying the index of the element, and in remove, you specify by actually specifying the element itself. The next method is erase method. Erase method will erase all the elements of your list, and the syntax is list dot clear off. Then you have the del operator. Del method will remove the element at the specified index location from the list. And the difference between del and pop is in pop method, the removed item will be returned. But in del method, the removed item will not be returned. So syntax is del and then the list name, you can specify the range A:B. So then the elements within the range A to B will get deleted by using this method. You can also delete by specifying del and then the list name, and then the index of the element which you want to delete can be specified within square brackets. Say for example, here I have a list called list2 which contains 5 elements 1, 2, 3, 4 and 5, and then I say del list2 and then within square brackets I specify 1, which means 1 is the index of the element I want to delete. So 0, 1. At the index 1 I have the element 2. So the element 2 gets deleted, and when I print list2, it contains only 1, 3, 4 and 5. If you want to sort, arrange the elements of a list in increasing order, then you would be making use of sort method or the sorted method. The syntax for sort method is the list name dot sort of. The syntax for sorted method is sorted, and you have to specify the list name which you want to sort within the brackets. If you want to reverse the elements of a list, then the syntax is reverse of, then the syntax is list name dot reverse of. And if you want to count how many times a particular element appears in a list, then you will make use of the count method. And the syntax is list name dot count of the element. This will return the count of the number of times the element appears in the list. Say, for example, here I have created a list called as Z, which contains 5 elements, 11, 12, 13, 14, and 15. And then I say Z dot append of 16. I'm giving just one element here. And when I print Z, the 16 is appended at the last position of Z list. And then I create another list, Y is equal to 1, 2, 3. And then I say Y dot append of Z. So here Z is another list. So I'm appending the list Z with the list Y. So you can see that I already told you append function will not merge both lists. So when I pass a list as argument to the append function, the second list Z list is appended at the last position of Y list, but then it is not merged. Then you have X is equal to ABC. Then I say X dot extend of Y. I have created a list called as X, and then I say X dot extend of Y. Y is another list. So when I use the extend function, you can see that both of the lists are merged together. So X contains A, B, C, and Y contains these elements 1, 2, 3, and then another list which contains 11 to 16. Both the lists are merged together when I use the extend function. Next, I use the insert method. I have to specify the position followed by the element. I insert the element D to the list X. X contains A, B, and C. So I say at the position 3, insert the element D. So 0, 1, 2, and at 3 position, D will be inserted. So I say A, B, C, and D. Okay, so here this is the current contents of list X. In this list, D has been inserted and it now appears like this. And then I say X dot pop off. So in the list X, I have not mentioned any index. So it means it will delete the last element of the list X. The last element of list X is this list, to the entire list, which contains elements from 11 to 16. So that entire list, which is at the last position of list X, will be deleted and it is returned by the pop function. Next, I say X dot pop of 3. Here, I have mentioned the index of the element which has to be deleted. So 0, 1, 2, and 3. At the index 3, I have the element D. So that is deleted and it's returned by the pop function. Next, I say X dot pop of -2, which means second element from the last. Second element from the last is already this 11, 12, 13, 14, 15, 16 is deleted. Second element from the last is, this is last element, second element from the last is 2. So 2 is deleted and it's returned by the pop function. So when I finally print X, I'm getting the elements A, B, C, 1 and 3 in the list. And then I use the del operator and then I say del, the list name is X. And then I specify the range of elements to be deleted. So 2 to 5, the range is 2 to 5. So 0, 1, 2, 2, 3 and 4. The elements within the range 2, 3 and 4 will get deleted. And the final elements in list X would be A and B. Similarly, now I create a list called A, which contains elements 1, 2, 3, 4, and 5. And when I print A, it prints it. And then I use A dot reverse of. This will reverse the elements of the list. So here you can see the elements have been reversed for the list A. And then I say A dot count of 4. It will count the number of times the element 4 appears in the list. 4 appears in the list one time, so it will be printed. And then I use the sort function. Sort function. Now the list A is 5, 4, 3, 2, and 1. When I say A dot sort of, the elements will be sorted in ascending order, and you can see it's being printed in ascending order here. Next, I create another list called as C, which contains 78, 12, 3, 89, and 2. And then I use the sorted function. So for sorted, I have to use the sorted function and then pass the list name. And then I'm storing it in D. When I store it, you can see that the elements have been sorted in ascending order. For sorted, I can use a parameter called reverse. If I don't want to sort in ascending order, I want to sort in descending order, then I say reverse is equal to true. D is equal to sorted, and then the list which has to be sorted, the list name is C, and reverse is equal to true will sort the list in descending order. So now you can see that the list D has been sorted in descending order and it's being printed here. Next is accessing the elements of nested list. You can see I have a nested list here called as new list, which contains the elements 1, 2, and then another list inside it, which contains elements 3, 4, and 5. Now, if I want to access the elements of the list which is present inside this new list, then what I have to do is I have to mention the list name and then the index of this list. So this is 0, this is 1, and this is 2. So in 2, the index of, if you want to access the element 5, then the index of this element 5 within this list is 0, 1, and 2. So again, I give 2. So now it will return the element 5 for me. This is how you access the elements of a nested list in Python. So if you want, you can also access the element of nested list using negative index. Instead of giving 2 here, if you are counting from the last, then it would be the last element has the index -1 in Python. So you can say, instead of saying new list of 2, you can say new list of -1. So the last element is -1. And in the last element, the index of the element which I want to retrieve is 2. So it returns the element 5. Next is list mutability. The meaning of list mutability is the elements of the list are mutable. That is, it is possible for us to change the elements present inside a list. Say, for example, I create a list called as X and it contains the elements 1, 2, 5, 7, and 9. And then I say X of 0. So that means in the index 0, the element present in the list X, the element present in the index 0 of the list X is 1. Okay, so I also say X of -5, which means the fifth element from the last. 1, 2, 3, 4, and 5. Fifth element from the last is also that first element. So it returns 1. Now I change the first element of list X by saying X of 0 is equal to A. As I told, list is mutable. So when I'm changing this element 1 to A by accessing the index. X of 0 is equal to A. Now the first index element has been changed to A. And then when I print the list X, you can see that 1 has been changed to A. So this is how you alter the elements present inside a list, and it is called list mutability. Next topic is called list aliasing. What is the meaning of list aliasing is, let's say I create a list which contains 3 elements, 1, 2, and 3. And then when I say A is equal to 1, 2, 3, it means I'm associating a variable called as A with a list object. So this association of a variable with a list object is called as reference. I'm creating a reference to access the list object. So now A variable is referring to the list object, and the values of the list object are 1, 2, and 3. And then later, if I say B is equal to A, it means I'm creating another variable B, which is also referring to the same list object, which is also associated with the same list object. So now we have 2 variables B and A, and both refer to the same list object. Okay, B, if I say B is equal to A, it means 2 references A and B are pointing to the same list object. And when I use the is operator in Python to check whether both are referring to the same object, when I say B is A, it will return true. So here this concept is called aliasing. A and B are said to be aliases or alternative names for the same list object. Okay, and this phenomenon is called as list aliasing. So here in list aliasing, you can see that you have 2 variables A and B, both are referring to the same list object. And if that aliased object is mutable, whatever changes you make with the one alias will affect the other also. Here in our case, list is a mutable object. So if you make change in A, it will be reflected in the reference B also. say for example, here I am creating a list called as C, which contains the elements A, B, C, and D. And then I am creating an alias called as D. And then I say D is equal to C. That means here both the variables D and C are aliases which refer to the same list object. So when I say print C or print D, it is going to print the same elements A, B, C, and D. So I have two aliases C and D pointing to the same list object. Later, when I say D of 1 is equal to E, that means I am changing the element at the index 1 of the list D to E. And then I am printing both C and D. Okay, so you can see that even though I have made changes in the list D only, it is reflected in the list C as well as in the list D also. Okay, so this is because list is mutable, and when you create an alias for a list object, whatever changes you make in one alias will be reflected in the other alias also. So you can see that after making the change also, if I say I use the is operator to check whether both D and C are referring to the same list object, it returns true. That means they are referring to the same list object. So that is about list aliasing. Next topic is about cloning lists. The meaning of cloning is creating an exact copy of the original object is called cloning. Why we have to create a clone is, let's say I'm modifying the elements of the list, but still I want to keep a copy of the original list. Then I will make use of this concept of cloning. But in the case of cloning, the two cloned variables may be having the same values, but they will not be pointing to the same object. So if you use the is operator and check, it will not be returning true. So first method of cloning lists is by using slicing, and slicing is done by using the colon symbol. So here you can see that I have created a list called as X, which contains the elements A, B, and C. And then I say Y is equal to X, and then simply the colon symbol inside the square brackets, which means this will clone the exact copy of list X will be created, and it will be stored in list Y. So you can see that later when I print X as well as I print Y, it contains the same elements A, B, and C. All the elements of list X will be copied and it will be stored in Y. And then when I change the element of list Y, I say Y of 1 is equal to M. Okay, so the element at the index 1 of the list Y is changed to M. And then I print Y. You can see that at the index 1, the element has been changed from B to M. Then when I print X, you can see that it has not changed the elements of the list X. In list aliasing, just now we saw that it will be changed in both the aliases, but in list cloning, you can see that even though I have made a change in the list Y, it has not affected the list X, and it remains the same with its elements A, B, and C. So another way to do slicing is by using colon operator. You can do the same thing with the colon operator also. If I say Y is equal to X and then the colon within the square brackets, and then I print Y, the same contents, the contents of X has been copied to Y and it's printed here. The next is you can copy the list by using the copy method, which is the built-in method of Python. So just specify the list name dot copy of, it will copy the list and it will return the copied list. It will not, does not take, this copy method does not take any parameter. It will just return the list. You can see that I have a new list here, which contains 12, 24, 36, and 48. And then I say new list dot copy of. I'm calling the built-in copy method of Python. And then I'm copying the copied list into copy list. Later, when I print new list and copy list, both of them are containing the same values. I can also copy list by using the list of method. Now this list is a constructor method in Python, which will return the sequence of list elements, which you can modify. So here the syntax is list, and within the brackets, you have to specify the name of the list to be copied. So C is equal to 5, 6, 7, 8, and 9, which is a list. And then I call the list method and I call the list constructor and pass the list C to it. And then the copied list is saved in D. Later, when I print C and D, you can see that both of them are containing the same values. The next method is next method of list cloning is by using, you have a module called as copy module in Python. You can do shallow copying by using the copy method of the copy module, and you can do deep copy by using the deep copy method of the copy module in Python. What is the meaning of this shallow copying is, it is not recursive. That means when you have nested objects present in the list to be copied, then copies of child objects will not be created. A shallow copy will construct a new compound object and it will insert references into it of the objects which is found in the original. It will insert references of the original object into this newly created compound object. So only references will be created. So it will not be independent. When you have nested objects present within the list to be copied, then whatever changes you make in the nested objects will be reflected in the copied object also. So here you can see that I have new list which contains 12, 24, 36 and 48. And then when I say since I'm using the copy method of the copy module in Python, I have to import by saying import copy. And then I say copy.copy of new list. I call the copy method of the copy module. I say copy.copy of new list. And then I print copy list 3, which contains 12, 24, 36 and 48. You check whether copy list 3 and new list are referring to the same object. Here it is not. So in list cloning, both of them are not referring to the same object, even though they contain the same variable. So it returns false. You can also do copying of the list using the deep copy method, and the syntax is the copy module name dot deep copy function and the name of the list to be copied. The last is you can copy the list using the extend method. So you just create an empty list and then you say empty list name dot extend and then the name of the list to be copied. So elements of one list are copied into another list by adding them to the end of the list using the extend method. Here, not only list, you can also specify a set or a tuple can also be passed as arguments to the extend method. So here, this example illustrates the difference between shallow copy and deep copy. As I told before, deep copy creates independent copy of the original object and all of the nested objects of the original object. So here you can see that, so whatever changes you make in the original object and all of its nested objects will not be reflected in the copied object when you copy by using the deep copy method. Say for example, first I import the copy module and then I create a list which contains another nested list 1, 2 and 3, and in the nested list I contain the elements 4, 5 and 6. And then I create a list called as B using the shallow copy method. I say copy.copy. So I use the shallow copy method of the copy module and then I pass the list A. And then I say C is equal to copy.deep copy of A. I use the deep copy method and I copy the list A and I create another list called as C. And then I print B and then I print C also. You can see that both the copied lists B and C contain the elements of the list A. So, and then here you can see, I try to change the element of the original list A. I say A of 3 and 0, which means at the index 3, 0, 1, 2 and 3. At the index 3, I have the nested list. And in the nested list, at the index 0 of the nested list. At the index 0 of the nested list, I have the element 4. I'm changing this element 4 to Y here. Okay, now I have made changes in the original list. I have changed the first element of the nested list from 4 to Y. And then now I try to print the shallow copied list. I say B of 3, 0. B is you can see that this is B. In B is the shallow copied list. And in B also in this position 4, I'm checking what is the element present now. You can see that in the shallow copied list also, since the nested objects are not copied directly, only references will be copied. So when I make changes in the original list, nested object of the original list, it has made changes in the shallow copied list also. And then I try to print the deep copied list. I check whether it has changed the elements of my deep copied list. My deep copied list is C here. And then when I check what is the element present in the index 0 of index 3, 0, 1, 2 and 3. So here the element 4 remains as such. It has not changed because C is a deep copied list. Deep copy creates independent copy of original object and all of the nested objects of the original object. So list C, which is a deep copied list, is unaffected by any change in the list A. So this is the difference between shallow copy and deep copy in Python. That is all about list mutability, list aliasing, and list cloning, and all of the list methods in Python. Thank you.